Hello everyone, can you hear me? All right. So, okay. All right. So we were discussing about I think the seventh session. Just give me a minute. Just give me a minute. All right. All right. So hi Arvind, Girish, Carl, Kirpa, Praveen, Santosh, Shavita, Subbareddy. I'm hoping that my voice is clear to everyone, and we will continue our discussion from where we left. I think we left at NoSQL. So we discussed about CAP theorem. CAP theorem says that out of CAP, we can only have two at max. We cannot have all consistency, availability, and partition tolerance. Then we talked about what does it mean by column-oriented database. Column-oriented database is based on the storage. If we store the columns together, column values together, that means we might get a little bit of a benefit of compression. So great. So we also talked about the column family oriented database. Afterwards, we went ahead with definition of HBase. A quick overview was given on HBase architecture. Afterwards, we talked about master and region servers. Yes, thank you, Subbareddy. Today, this time I have started the recording. You can see, do you see that the session is being recorded at the bottom of the webinar? Yeah. So thank you for reminding. All right. We also discussed about the architecture where there is a master and the region servers. Region servers store the actual data while master stores the information about which region is where, and a region is marked by a table it belongs to, the first row and the last row. And that is very much visible from this diagram where it shows that the first region, which is starting from the key called T to Z. Okay, so as we say that every row is identified by the key called row key, and based on the row key only, we decide upon the regions. All right, so now you can very well assume that in case in case for certain keys, let's say for keys A to C, there is a huge demand from the user side. So this particular region server having this particular set of reason of a table, then this particular region server will get a lot of requests while other region servers will be fairly free, and effectively we might end up in overloading of region server. Okay, if there are so many requests only for these set of keys, that traffic may not be that traffic may not be distributed. This is called region server hotspotting. To avoid region server hotspotting, people generally split the region into multiple regions, and that solves a lot of issues. Okay. All right. Afterwards, we also discussed. All right. Now, good. What is the reason? We have a question from good question from. I have saved this. Okay, I have saved this session. Let me create a new one. All right. So I'm storing these question answer from all of you, and we'll see if I can put them in the LMS. So Girish is saying, what is the reason for not having all the three caps? You mean CAP, right? Consistency, availability, and partition tolerance. Okay, okay. Subba Reddy, and there is another question from Subba Reddy, uh, which is keys add will be there on region server in this scenario since it is closed with this. Let me have a look. Correct. So very good question, Subba Reddy. So here it shows that the Z1 is having a round here. You see the round, and therefore it means that there is no place where Z is being stored. Very good catch. So ideally, we should generally say T dash some slash zero, for example. Okay, T dash slash zero to mark the number after the Z. Okay, all right. This is for representational purpose, Subba Reddy. I'll take that into account. So basically, let me rephrase what are we trying to say. When we say round bracket, this comes from our set theory. I think it comes from number line. It comes from a number line where we have a square bracket on one side and the round bracket on other side. And this is generally for used for ranges. So it says that on the left hand side it's closed while on the right hand side it's open, which means A is included in this range while C is not. C is included in another region here. Okay, while F is included in this region, not this region. And similarly here, so this is just a representation. So it's interesting thing to note that Z is not in any of the region servers. Okay, so ideally we should have some other character instead of Z to mark the ending. Good. All right. Now let me try to answer. So there is a question from Girish. The question is, what is the reason for not having all the three things mentioned by CAP? C means consistency, as in even after we access the data, even after a microsecond, if we access the same data which we had just written, we should always get the data we have written. We should not get an older data. That is consistency. Whatever we have written, we should get that one, not some older or not something else. That is consistency. Availability means no matter how many requests are there, every request, there is no request which goes unanswered, meaning all the requests need to be answered, whether failed or successful, but every request need to be answered. Third one is partition tolerance. That means in case some of the machines shut down in the network, at least starting with at least one machine shuts down in the network, still your system should work just perfectly fine. Okay, either of the machines. So we discussed about cap theorem. Cap theorem says no matter what you do, you can never achieve all the three things. And the best way to describe it, after thinking a lot, after giving it a lot of thought, best way to explain it was these three diagrams. I thought about all possible permutations of network architecture. I could come up with only these three diagrams. Okay, which says the first one says that First one represents the relational database, in which there is a single machine, everybody is reading from it, and everybody is writing to it. And the second one is sort of our MongoDB kind of architecture, where we write to one, read from another. Then I then the third architecture which I thought about was A to B. Okay, where there is a server A where read and write are happening, but B is I mean, B is only used as a backup. Okay, so out of these three architectures, or combination of these three architectures, is what builds up most of the systems. If you think about name node and data nodes, they all follow the last one. Sorry, name node and secondary name node, they all follow that name node and secondary name node follow the last one, as in we read and write only from the name node, and not and there is a backup for the replication. So it is heavily consistent. Okay, but it is not highly available. So that is why we call it C and P. Same is the case. This last one, I will make a note here. So this one, you have HBase and you have HDFS, both here in the same manner. Okay, so HBase and HDFS lies here, while while we have MongoDB, Zookeeper in this arena. Okay, okay, I'm just trying to write down their names, and this is our traditional RDBMS. Okay, so these are the three kind of architecture I could think of. If you can think of a better system, I'll be more than happy to help you with that. Okay, so when I studied almost all the systems which are distributed in nature as well as normal one, they fell into either of these buckets or a combination of these. Okay, so they all fell into one or the combination of these ones. So if you look at it closely, this is our traditional database. We read and write to it. Then if you look at it closely, the reader will keep on reading the older data unless the data this user has written reaches here. So there is a time delay from A to B, and that's what is causing the inconsistency. These systems are eventually consistent. We call them eventually consistent. So let me try to write here. This will look better. Eventually consistent. Okay, eventually consistent is not same as consistent. It says that believe in God, everything will be all right. After some time the data is going to reach on the B machine, and eventually things are going to be consistent. But right now you are going to live with the older data. Okay, so it's not consistent, it is eventually consistent. Now, when you look at all of these three diagrams, if you have any other in mind, I would be more than happy to discuss that. Do you have any other architecture in mind for storage? Anyone? Are these three diagrams clear to everyone? If it is not clear, I'll be more than happy to explain to you, because these things are the basis of all the distributed databases. So these are the three kinds of architectures which are there, or a combination of these architectures. So if you have some other architecture in mind, I would be more than happy to discuss. So in one, you have a single machine, you do every operation on the same machine. In the second one, you built a really clever one where writers and readers go to different machines so that this single machine's work has been given to two machines. In the third one machine is busy and all the users are reading writing from that one, and a backup copy is maintained so that in case A dies, we have B ready to take its place. All right. So, Srisha's question is, so in MongoDB and Zookeeper, data is not consistent. So, I mean, we want to add nice words to inconsistency here. We say that data is eventually consistent, meaning you might be reading an older data. You might be reading an older data, a little older data, but eventually the data is going to be okay. All right. So, and Zookeeper makes sure the this whole mechanism make sure Zookeeper does a lot of work. We will explain to you in the Zookeeper session. So, any questions up to here? Girish, are you with me? All right. So, do you think there is any other architecture when you think about systems? Is there any other architecture when we talk about databases? Communication between the user and the databases. All right. So, and if you look at it closely, no matter which kind of architecture you choose, we were not able to provide the consistency and availability at the same time. Either consistent or available or partition tolerance. Okay. Okay. Does that answer your question? All right. We have a good question again. Let me. It's going a little faster. All right. Girish is saying if we add if we add two additional A to B, you mean the first diagram? Okay, okay. So let's say what Girish is saying that A plus A and then connected to B, and the user is talking to who? You mean the writing is happening on A and A? There are two clones of A. So if you so in any case scenario, you never have more than one machine which is accepting the writes. Okay, if you have multiple machines which are accepting writes from the user, they can never be consistent. Okay, all right. So we have okay. Let me try to read his point. So if we add two additional A's to B, I mean A plus A arrow B, the third one, and A. Parallelly, they are talking to A. Okay. So all the users are talking to A. Do you want me to unmute you? So all the users are talking to A, multiple users are talking to A, and A is transferring data to B and one more machine. Is that what you're saying? Hmm. Should I unmute you? You want me to unmute? Okay, A is transferring to B, that is accepted. And all right, actually, I'm not able to understand. Uh, so either I can make you, all right. Girish is saying two parallel A servers can talk to one server. Yes. Do you mean to say that we have one A and let's say one B, and we have got C and multiple writers? These are writers, all the writers. Okay, and let me call them writers, and they are all talking to A, and A is transferring the data to C and to B, and readers are reading from both of them. Is that what you mean? Yeah. So if you look at this, so thankfully this is what Girish meant. Here also there are writers who are writing to A. A is transmitting data to B and C, and readers are reading from B and C. Okay. Is this diagram clear to everyone? So if you look at this diagram as well, what is exactly is happening here? So let's say you just wrote some data, okay, and quickly started reading the same data which you have just written, okay, and you will notice that still the database is still having um, for an end user, this is how it will look to you. There is this boundary of the database. Okay, this circle depends the boundary of the database, and these are the readers and these are the writers. So if a writer comes in and writes some data to A and immediately reads it after a 1 nanosecond, whether from B or C, he will see the older data because it will take some time for data to flow and reach till B or C. Okay, and therefore this will be eventually consistent, not immediately consistent. Does it make sense, Girish? All right. So this is actually a typical MongoDB kind of a model where we write to one and it transmit to all the, we call them the shard servers, and there is always a primary and secondary. A is a primary, B and C are the secondary, and A is designated with the role of a writer, and the designation happens via voting. Okay, so make sense to you now? Is cap theorem clear to everyone? Great. So I'm moving on. If you have any questions, feel free to ask. All right. Let's not pretend that we have understood things. If there is any doubt anywhere, feel free to ask. Okay. There is nothing wrong, and you will be surprised that whatever doubts you have, other people might be having the same doubts. All right. Good. Moving on. So we talked about various kinds of parts of the data model. Okay, we talked about what is a column family, what is a column, what is a cell, what is a version and time. Then we talked about a logical representation in the diagram. Afterwards, we also talked about the physical view. This is not very helpful, and this is what we discussed. Okay, this data model, is it clear to everyone? Okay, Subbareddy is saying, can you explain about web table? Who else want an explanation on this? Great, great. So Srisha is also asking for the same thing. All right, awesome. Let me just take a step back and we all work together to describe what exactly Google did. So Google's role was to form the index. Okay, so let's say there was one website called www.cnn.com. Okay, this one. Now this website had some nice pages. Okay, it has some nice pages, and it says, "Hi, I am cnn.com." All right. Of course, it will have a large amount of HTML and far more complex one. Okay, so sounds good. So this is our cnn.com, and this is what their data is. All right. Now there is another website called cnnsi.com. cnnsi.com. Now this cnnsi.com is having its own HTML. Okay, it is having its own HTML, and let's say, "Hi, I am CNNSI." And under this, it also has, of course, there is a body tag. I'm not writing body tag. This is inside the body tag. Okay, it has a reference to CNN with the name CNN. Okay, and not this. It is having www.cnn.com. Okay, it's having this reference here like this. All right, then there is another reference here with the name cnn.com, and not this one, I'm sorry. All right, so that's pretty much about the HTML in cnnsi.com. Then there is another website called mylook.ca. Okay, and let's say that it only has this much. Okay, it will have its heading, title, whatever. It also has a reference. A href means it's a link which will display this CNN. If you click on this, you will go to this website. Okay, so you can see that cnnsi.com is referencing cnn.com, and mylook.ca is also referencing the back the cnn.com. All right, so there are these three nice websites. Okay, now let's say, now Google's role is to find about all these websites, crawl their data, crawl their data, and then find the details about these websites, crawl their data, bring the data to their servers, and then index it so that it can also do the computation. Who are the websites referring one particular website, so that it can apply its PageRank algorithm and figure out that what is the page rank and other strengths of a website. So since CNN.com is being referred by CNNSI.com as well as my.look.ca, that means CNN.com has got the higher page rank. All right. So these kind of computations Google need to do. Now, what they did was they first stored this data into the web table. Okay, so they created one table, one HBase table, or they call it big table. And under this, the row key is the domain name. Row key is the domain name, this one. And the contents is the HTML one. Contents is one of the column families. And under this, as we said, that column name can be empty, column name can be a binary data, as well as the row key can be anything. Okay, so there is a default column with an empty name which we have designated for HTML. In case the data is in PDF, we could have one more column under the same column family called contents and store the data there. All right, and that's it. Initially this is how it is going to look like. So can I make a nice spreadsheet? So you can think of a table like this, big table like this. Okay, in which there are these column families called, these are contents. Okay, under this we are adding columns. Okay, so the columns and this is our row key, so our row key is this. Let's assume this first time, and the content of this one we are going to store in the first column. If we had one more kind of a content, then we could have added one more column in the same column family. Again, columns can be added into a column family at any point of time. Any number of columns can be added into a column family at any point of time. The way we keep on adding rows to our database, the way we have been taught to add as many rows as we practically encounter into an RDBMS, in the same way, here we can keep on adding columns inside a column family, and these columns can go up to billions. Okay, so there is nothing wrong in creating one more column under the same column family called contents. All right, so we could also have one more. Now this is done. We are done with this one. After some time, we encountered cnnsi.com and we created a row key. This is a row key. All right. Let me just color it for a good effect. And let me give it a background. This is not good. This is better. Okay. This is little too. Yeah, this is better. Okay. All right. cnnsi.com. See that? Now, while while Google tries to understand the website, it found that this website is actually pointing to cnnsi.com. So to make a note of it, it inserted one column into the column family called anchor. Okay, so this table had anchor column family already. It created an anchor called it created one more column called anchor colon cnnsi.com, and basically it added cnnsi.com anchor dot colon cnnsi.com a column into this table, and here it only mentions that this website is referring to it as CNN. Okay. Similarly, after some time, it noticed one more website, crawled one more website, downloaded its data, inserted the data into HBase, and then let me make this column a little bigger. Yeah, now it makes sense. And then it noticed that, oh, this website, after parsing the HTML, it noticed this also is pointing to www.cnn.com. So it made one more column called anchor colon. This time it's my.look.ca. Okay, this time it's mylook.ca, and is being referred as, anybody? Is being referred as cnn.com. Now, if you look at it, the row keys which has more number of columns under a column family called anchor has got more number of back reference link. That means that that particular website will have the higher page rank. Make sense to you? So was I able to explain how is Google forming this kind of? There is one bit remaining. I will talk about this bit in a minute. So any questions? So Srisha's question is, doesn't it need more space? Probably you are fearing that since we are adding arbitrary columns, let's say cnnsi.com is being referred by Microsoft. Okay, let's say Microsoft is referring back cnnsi.com. Okay, so there will be one anchor called microsoft.com is referring to cnnsi.com as, let's say, cnnsi, right? And there'll be one row here saying microsoft.com and some html, and will be some html. Okay, so you can see that these cells are empty. Okay, we can remove this cell for time being because we have no values in it, so it doesn't make any sense. So these cells are empty, this is empty, these are all empty, so it might give an impression that this space is being wasted. Right, that's correct, Damodaran. Yeah, so yeah, every time we will be creating more and more. So if Microsoft is pointing to all these websites, let's say Microsoft is also having an href to cnn.com, it will not create one more column separately. Instead, it'll mention here, okay, CNN. And in case there is one website which is referring to all, then there will be, that full column will be filled. So most likely, so you can see that the first impression you get is, oh, all of these are going to waste my space. But the way HBase or the way Bigtable was designed to be sparse in nature. If you let me take you back to the main definition. Let me take you back to the main definition. Here it says the first word as sparse. Okay, so sparse table does not hurt HBase or Google's Bigtable. All right. So everybody okay with this? So sparse means scarcely populated. Okay. Only some columns are full. Most of the columns are empty. You can see these are empty. The one which I'm marking as this. See that? These are all empty. All right. Now there is one bit which is still pending in the description. Even this is empty. Okay. There is one more bit that is pending from the discussion, and that is, all right. Let me also make it like a holy colors. All right. Here, that one bit is, what if there is another website we encounter with a name like blog.cnn.com, or we call it, say, email.cnn.com, okay? Or we call it in, the, let's say, mobile.cnn.com. Now, if you sort this data, there are chances that all the websites of CNN will never come together. Let's say we sort this data. We go here and say sort. This table has and we sort it by A. Okay. Now you see there is a blog.cnn, then CNNSI, then email.cnn, then Microsoft, then this, right? So since it says clearly when we discussed earlier that it is easier to read the next row than jumping forward. So if we have to access all the websites of cnn.com, we'll have to keep searching again and again. Okay, and effectively we'll also have to track down that what are the various websites having a domain name as cnn.com. Since this table is always sorted by row key, so we could have utilized that information that this table is sorted by row key, and hence we could form the key such that the data which we need frequently together, we could have kept that together. And how can we make sure that all the websites of cnn.com come together? Okay, the way that can be done is forming a new kind of a key by reversing these things. Reversing as in com.cnn.blog, com.cnnsi, com.cnn.email, com.micro, micro, okay, com.cnn.mobile, ca.look.my, com.cnn.ww. Now, if you see what we have done, we have basically reversed the order. Okay, reverse the order, and therefore now if you sort it, if you say sort my range, and table has a header and sorted by the column number B. Now have a look at it. So all the websites of cnn.com are coming together. Therefore, because here we are utilizing the property of a H-base table, that our table is always sorted by the row key. So whatever data you want to keep together, whatever rows you want to keep together, you should design the row key such that those are automatically together, so that to hunt for all the data, you do not have to keep searching. Okay? Make sense to all of you? So let's take a look at the diagram again. Now have a see. The com.cnn.www is what is our row key here. Great. So keep all of these things, keep all of these properties again in the mind while designing your architecture, because there is going to be one question after this session in which you have to design your email system to store millions or billions of emails in HBase. And trust me, using HBase, storing a billion email is not a big deal. Okay, storing a billion email efficiently is not a big deal if you use HBase. And probably in those kind of circumstances, you should always use a system like HBase, because it's really efficient to handle millions or billions of columns and billions of rows easily. So HBase is more like a big matrix, okay, um, big table in which columns also keep on increasing and rows also keep on increasing. So big table is, again, the same definition is very powerful and important. I could not take a single word out of this definition. This definition is, big table is okay if it's sparse. Big table is distributed, meaning multiple machines can store the big table. Persistent, as in whatever you store into big table does not get lost in case a machine turns off or you come after some time. Is multidimensional, as in it has got many columns, it doesn't have only the key value. And it's a sorted map, as in it has got key and the value can be multidimensional, meaning my value can have further records. So if you have a look at this diagram, so this is our key, not this is our key finally, because this is to be deleted. Let me just hide it for time being. This is our key, this collection is our value. Okay, so it's basically multi-dimensional sorted map, sorted because it's sorted by the key. Okay, so every word in this definition makes sense. All right, so this was our description about web table. The only information which we have not used so far is the timestamp. Okay, the timestamp, we can use, so each cell can have three values. Right now I'm not able to depict it here, but it could have three values. the most the latest value is always the current value, and the previous two values can be retrieved based on the version number. You can tell HBase that give me the previous values as well. All right, so are we all on the same page? So when we are designing an HBase database, these are the guidelines. Indexing is based on the row key. Tables are sorted based on the row key. Each region of the table has sorted row key space, which is starting and ending, meaning since the data is sorted by the row key, it's sufficient to make a note of starting point and ending point to predict which keys are where. Okay, because if we know the reasons starting and ending point, and we know that everything in between is actually in between of these two values. Okay, therefore we can make use of all of this information. The one thing which we need to make sure is the only atomicity which is guaranteed, atomicity as in either the transaction happens or doesn't happen. There is no middle state that half of the transaction has happened. That is atomicity. If we are writing to a data, either it happens or it doesn't happen. There is no midway. Or if we are increasing the value of a counter, if we are increasing a value of the counter in the middle state, there should not be anybody else which changes the value. Okay, it should not happen that two readers are reading from a value they read at the same time that wrote afterwards. That means it will introduce inconsistency. Therefore, atomicity means that no matter what happens, a transaction is never in the midway. Either it happens or it doesn't happen. So the kind of atomicity which HBase promises is that we give you a row level atomicity. If you are modifying a row, whether you are adding columns to it, you are adding, changing the data, or you are deleting the data, the only consistency, the only consistency which HBase promises you is, I mean, only atomicity which HBase promises you is for the full row. There is no multiple row transaction. The luxury which we had at the time of relational databases, the luxury we had was you could add 10 rows in one table, delete 5 rows in another table, and you could do all of this in a single transaction. That kind of luxury we do not have in HBase. The only luxury we have is we could modify as much as possible this particular single row without losing the atomicity. All right. Column families have to be defined upfront at the table creation. You don't have to define column names. Column qualifiers are dynamic and can be defined at right time. They are stored as byte array so that you can put data in them. Okay. So you could utilize the column name, row key, as well as the cell to store the data. All right. And also you could utilize the version numbers to keep the past history of the data. And whenever we are retrieving data, the the order in which we retrieve the data is, this is the sorting order in which we retrieve data. The data is first sorted by the row key, then by the column family, then by the row, the column qualifier, then by the timestamp. This is the only one which is in the descending, rest are in ascending. All right. So far, we have not showed you the database table. I think a better strategy would be to create a table and then show you where is my data. All right. Let's try to do a hello world with HBase. And before that, let's have a look at confirmation that our HBase is running. All right. So there are all these region servers right now are down. Let's just select this action, selected host, region servers, and start. All right. Now it should be up very soon. Okay. And this, not this, yeah, here we are. So we have HBase shell. Using HBase shell, we can execute the commands of HBase. And HBase provides you extremely simple API. This API is not like your SQL. It is very simple. You get and put. Just like the features you always got in map or hash map, you get and put in HBase. Okay, so let's try to interact with HBase here. So we started it, and let's check the status. Let's check the status. So it says that 3 servers are up, 0 dead, and average load is this much, which is okay. And let's try to create some table here. It says that the table already exists. Okay, let's disable it and delete it. Okay, so we have dropped the table. Next is, let's have a look at what all tables are there. So these are the tables which are available in our HBase. Okay, now let's try to create a table. Let's try to create a table called my table. It has got only one column family with the name called myCF. All right, you could give it any name you want. So we are creating a table, my table, which has got only one column family. So while creating a table, you should be very clear about which column families are you going to have in this. Okay, which table column family are you going to have in this? Now let's check if it has been created. So my table has been created, and we can also do things like dot star my table. Okay, so we could use a regex to filter out whichever table which we are looking for. Okay, and we can say scan and give the table name. Let's say this time I'm giving table 1 or table. So it's saying that there are 0 rows. Next is we could put the data into our table. Our table name is my table, and we are saying that into this my table put this row and these column values. Okay, it says that row 1 mycf dot column 1, that is the column name because it includes the column family as well, and then this is my value. Let's add some value in this and say scan my table. Now you can see that it has got timestamp, it has got value. All right, this is how you add the data into the table. Okay, if you have to get a particular value, you could say things like this. You can see that it is giving you the column, the values for this particular column. All right, you could also see the details about a table by saying describe my table and go into the details. Afterwards, you can simply disable a table and then delete it. So it's important to disable a table before deleting it, because disable a table essentially stops all the writing and new readers to the table, and it waits for existing readers to finish the work.